So continuing with that pre-algebra, algebra problems theme, um, we get a lot of questions about graphing in Get More Math. In fact, I think the training team put together an entire video for students just about how to do graphing problems in Get More Math. So could you talk a little bit about just what those problems are requiring, why you wrote them the way that you did, and just talk about graphing and Get More Math?
So once again, you've asked me a question that could be its own podcast. So I'll try to keep it medium short. I won't try super hard though. Robbie, when I made Get More Math, I could finally um, bend kids' minds into the shape of understanding more about linear relationships than they ever had before. In ways that when I was having them do paper practice, I never arrived at some powerful gains that I could arrive at when I started designing the skills and getting kids to think more and deeply and engage more completely with the concepts. Okay. So what's happening with graphing is I'm pushing kids' brains in different ways towards a broader and a deeper grasp, both of fundamental algebraic concepts related to relationships and how relationships are made out of pairs of numbers. And they're answering that question as you increase one variable, what's happening to the other one? I can really deepen their power with problem design. So, for example, when I was a new teacher, I thought rise over run was the bomb, right? Hey kids, if you have y equals 2/3 x plus 5, put your pencil at 0, 5, go up 2, go over 3, make another dot, connect the dots, you graphed. That's what I thought was a wonderful thing. What I realized over time was it's almost meaningless. Like kids could do it, but it had no connection to algebra. It was just this procedure that they would do and be done with, and it was useless. It wasn't used for problem solving, wasn't used for thinking. In Get More Math, I deliberately found ways to bring more meaning into, say, y equals 500x minus 7 or something. Like, bring more meaning into the function as something that produces pairs of numbers and answers the question as you increase x, what happens to y? And to do that, I brought scale in. So as a new teacher, the scale was always 1. And at some point, I would try to get the kids to think about scale, but it was brief and it was hard and it was painful and they didn't get it. Not long term. But in Get More Math, from the beginning, I was having kids think in terms of scale. So day two, I'd have them do coordinate plane work with scale, where they had to plot a point at 300, comma 2. And to do that, they would have to choose scales that worked and estimate where the point would go. So scale is probably the first thing that I wove in throughout, always having to think through um, what each grid unit should stand for. And then another thing that I worked in was always trying to find ways to get kids to think in terms of pairs of numbers. So you'll see tables show up all the time. And that's because I don't want kids just using rise over run. I want them to think about, in this relationship, what are some key pairs of numbers that really express important moments in the relationship. So that's why tables are there. Another concept that mattered to me was the difference between sort of a real world graph in the first quadrant and the sort of abstract graphs in the four quadrants. So that's something you'll see, like if there's a word problem and it has to do with time and over time what's happening, you'll see we give just one quadrant. And we actually expect the representation that the student creates of all the pairs of numbers to actually model the real pairs of numbers. So in those scenarios, if a student uses a line, we don't permit that. We want a ray or a segment because we want the kids to be thinking about what are they showing? They're actually making a picture of pairs of numbers, the pairs of numbers that form the set that are in the relationship. So it doesn't make sense to say after -5 days, there were, -$500. That doesn't exist in the real world, -5 days. So another piece was uh, demanding the correct choices on lines versus rays versus segments. Um, so there's three sort of big thoughts that are kind of baked into the graphing. I'm sure there's more, but those are the ones that come to the top of mind.